ASCII conversion to hexadecimal numbers. Here we are going to take the input ASCII characters from 0 to 9, A to F, and we are going to convert those ASCII characters into corresponding hexadecimal numbers. So in this lecture we are discussing about basic instructions which are performing those conversion, and software demonstration how we can convert these ASCII characters into hexadecimal numbers. So first of all, we discuss these concepts in detail. First, the ASCII characters are written from 0 to 9 and A to F, and their corresponding hexadecimal numbers are written from 30 to 39, then 41 to 46. There are some numbers are missing over there, so these are some special characters like plus, minus, greater than, less than, or we are not going to take the input of those numbers. So in this case we take only 0 to 9 and A to F. So these 7 characters are left behind. So the logic is, if we enter 0 as a ASCII character, we have to show output 30 in hexa, and if we take input 0A, we have to show output 41 in hexa. So what is the logic behind this program? Here, if we enter ASCII characters from 0 to 9, we have to simply add 30 to that number. If a number is greater than 9 or less than 10, then we are going to add 7 plus 30 to that number. So we will get the output from A to F by adding 7 plus 30 in that number. So this is the basic logic behind this conversion. So how we can convert? Let us see complete program with instruction. Here we start our program by writing area program code, read only, then entry, and then main. After main, we are going to write our program. LDR instruction is used to load the register from any variable which is defined in this area, or it can be defined in a memory. So we can take the input from this variable. So here, area program data read only, in this section we defined digit as a variable which contain 0C ASCII character. So 0C is a load into the R0 register, and this R0 register is compared with 0A. Then we assign BLT instruction. BLT instruction is used branch if less than. If number is less than 0A, then it directly goes to the label of add 0 or add outer loop. So here we add 30 to the register R0. If number is not less than 10, then we add 7 and then we add 30. So in this case, these two instructions are executing with the help of this compare and BLT instruction. Let us discuss these instructions in detail. Here, digit which we are entering 0C is greater than 0A. So in this case, this instruction is true, then we add 7 and 30 to that number, so we get the corresponding result 43 across C. So this is the basic program how to convert ASCII number into hexadecimal number. So we are going to discuss this program in our software. Let's take a look. This is our program which is written in ARM assembly language. Here we have defined area program code read only, entry and main. After main, we have to write our program. This LDR instruction load the data from the digit into R0 register, then it compare with 0A. If number is less than 0A, then we directly add 30 to that number. If number is greater than 0A or equal to A, then we add 7 and 30 to that number. So we will get the corresponding result in this section. Let us look by compiling this program. Here is a build section where we execute our program, which shows that there is 0 error and 0 warning. After execution, we are going to debug our program. So after debugging, this window appears. We will start debugging step by step. So in first step, R0 is loaded with the number 02. So here we get R0 as 02. Then this 02 is compared with 0A, and our CPSR shows that there is no carry flag or overflow flag over there, but N shows it is 1. Means that number is less than 0A. We have to move to the outer loop at 0. So in next instruction, we will move to add 30 to that number. So in this case, our pointer moves from this instruction to directly add R0, R0, hash 0x30. So after this instruction 30 is added to the input number 02, so R0 result become 32. This is the final result of R0, which contain the result 32. As we have discussed earlier that 0 represent 30, 1 represent 31 and 2 represent 32 in hexa. So we will get 32 and here we get 32 as a result. Let us take another example where we take another input as 0C. We are going to change this number from 02 to 0C and we start debugging this program. It shows 0 error and 0 warning. Then we start step by step debugging of this program. So initially we load R0 with 0C, then we add this number is compared, 0C is compared with 0A, then this instruction is going to be false because number is greater than 0A. So this BLT add underscore O going to be false. So this instruction is not executing and we move toward next instruction, add R0 comma hash 0x07. So in this instruction we add first 7 to that number, so we will get 13, and after adding of 7 then we move further toward add R0 comma hash 0x30. So we add 30 to that number, we will get 043 output corresponding to 0C. As we can see, A represent 41, B represent 42 and C represent 43. So R0 register contain the result 43. In this way we execute our program in ARM assembly language.